to do this. There's another option. So first thing, just a couple properties. If you wanted to flip your limits, you do that by putting a negative in front. So if I said, okay, I want to find this area under this curve from 0 to 4. If I wanted to go backwards and find the area from 4 to 0, traveling backwards makes it a negative. Okay, so you can flip the order of these limits by changing the sign on your integral. Second thing, if you start and stop at the same point, you get 0. If I want the area under this curve from 0 to 0, I never went anywhere. So can you draw a rectangle and calculate any area? No, if you think length times width, you might have a height, but my width is 0, and anything times 0 is 0. So if these limits are the same, it's just an automatic 0. All right, so here is our wonderful nugget of the day, our important information here. If you have the antiderivative, which we know how to do antiderivatives, so it turns out this integral that we've been doing is the same as the antiderivative of the top minus the antiderivative of the bottom. Let me show you how that works. So if I wanted the integral from 0 to 3 of x squared dx, is that the problem we just worked out? Or very close to the one we worked out. What is the antiderivative of x squared? And we normally put a plus c with that, right? We are actually not going to have to do the plus c when we have a definite integral. And I'll explain why in just a moment. So this is saying we want to evaluate this from 0 to 3. After you do the integral, the notation is just put this vertical bar at the end to keep in mind your limits. So all that means is you plug in a 3 to your antiderivative, minus, and then plug in a 0 to your antiderivative. Yep, 1/3 times 27, so 9 minus 0, so the value of this integral is 9, which is the same answer we would have gotten if we had worked it out like we did on this one. Okay, using the whole limit and summation thing. This is a much shorter option. The reason you don't have to put the plus c on this antiderivative is if you did. So you'd have a c here, you'd have a c here. When you subtract, what happens to those c's? They're going to cancel out every time. So while you could put a c, it's not necessary since we actually have definite numbers to plug in. When you subtract, the constant would always cancel out anyway.
So if you have 3 and 0,
That's what you would plug in here. So if I had said I want the limit from 2 to 5, then I would plug a 5 in here and a 2 in here. Other questions? Let's skip this one. Let's stick with definite numbers for now. So if I want this integral, you had a trig function on your homework last night, but we just did the approximation. We just had a set number of rectangles. What is the antiderivative of sine? We're going to do negative cosine x. We're going to evaluate from 0 to pi. So you plug in the top number, so negative cosine of pi, minus, and then you plug in the bottom number, negative cosine of 0. So what is the cosine of pi? So the opposite of -1 is 1, minus, what is the cosine of 0? 1. Sine of 0 is 0. So minus negative, so plus 1, and we get 2. coefficients here? Why don't you guys try this one? So, antiderivative of x to the fifth is 1/6 x to the sixth. And I'm evaluating that from 0 to 2. So we're going to do 1/6 times 2 to the sixth minus 1/6 times 0 to the sixth. Another way to think about that, guys, you're welcome to just pull out that 1/6 since it's a coefficient, and then just do 2 to the sixth minus 0 to the sixth, and then multiply it 1/6. Either way. So you get 64/6, so 32/3. We good with that one? Let's try the next one. A little bit uglier. What is the antiderivative? So then we have the x squared minus. So if you add 1 to the power, -1/2 plus 1 is 1/2. Reciprocal goes in front, so that would be a 2. Minus antiderivative of 3, 1 to 9. $55. Is that what you guys got?
I messed it up and I forgot to do that antiderivative one, so I was trying to fix it.
Oh. Ben, did you get it?
I got 52, but I could
Okay.
just also got 50.
Okay. So yeah, that's 52. I think I wrote a 6 right here instead of a 3. Sorry about that. I wrote down 1 digit wrong. Okay. Is that one alright? Okay, let's look at this one. We have to be a little bit careful. Could I write this 3 times and multiply it out? Sure. Let's see if we can figure out the antiderivative without doing that. So what does the antiderivative do to your exponent? So we would add a 4. So then what do we have to have in front? Okay, now check. If you do this derivative, the 4 comes down, inside stays the same, subtract 1 from the power. But then I'd have to do chain rule. So times derivative of the inside, which would multiply it by 2. So what do I need to cancel that? A 1/2. So I need to actually have a 1/8 in front. Coefficients, you are welcome to factor those out when you evaluate. So if I put in a 1, 3 to the 4th minus, if I put in 0, 1 to the 4th, so 81 minus 1. going to do just a few more of these today. So, question is, what has a derivative of sine? Negative cosine. When you do the derivative of a trig function, the angle doesn't change, so it still has to be a 2x. But if you did this derivative, you would have to multiply by the derivative of the inside, which is 2. So to cancel that, I need a 1/2 inside. So this needs to be negative 1/2 cosine of 2x. I'm going to evaluate from 0 to pi over 2. So I'm just going to pull that negative 1/2 out. So I have cosine 2 times pi over 2 is pi, minus cosine 2 times 0 is 0. Cosine pi is negative 1 minus 1. Negative 1/2 times negative 2, so positive 1. Much, much faster than how we have solved these problems previously. Alright. What has a derivative of secant tangent? Derivative of tangent is secant squared. Derivative of secant is secant tangent.
What about derivative of secant?
So secant of pi over 4 minus the secant of 0. So cosine of pi over 4 is radical 2 over 2. Secant would be the reciprocal, so that's radical 2. Cosine of 0 is 1, so secant is also 1. I just get radical 2 minus 1. A square root is like what power? So when you do the antiderivative, you add 1 to that. So 1/2 plus 1. So that means we have to have a 2/3 in front. What else do we need? We need a 1/3 to cancel the 3. So we have a 2 ninths. From 1 to 5. Make sure you're plugging in the top number first. If you plug in the bottom first, you'll get a negative, or the opposite sign of what you're supposed to get. So if I put in 5, this 3/2, that means the square root cubed. The square root of 16 cubed minus the square root of 4 cubed. Square root of 16 is 4. 2 to the 3rd is 64. Square root of 4 is 2 to the 3rd is 8. 56. So 12 last. So suppose an animal population, P of t, initially numbers P of 0 equals 100, and that its rate of growth is given by this equation. What's the population after 10 months? So here is the rate of change. I want the actual population, what do we have to do? The antiderivative. Okay. I want the antiderivative, do you know from where to where? 0 to 10 months, because we couldn't have a negative time and we want to know after the 10 months exactly. Okay, so antiderivative of 10 would be 10t. Antiderivative of t would be 1/2 t squared. 0.06 t squared. So that'd be a t to the third, so 0.02. Secondly, but we're missing one thing. This is basically telling us how much our population grew by. So we added 170. How many did we have to start with? 100. So the total population would be what we started with plus the new members. So 200. All right. That is my stopping point for today. I have a handout for you. This is the handout for today and tomorrow, but really, you could do almost all of it today, 1 through 18.